Welcome to solverfy.
This is the answer to Chapter 19, problem number 63 from the Smith Organic Chemistry textbook. And in this problem, we're told that threonine is a naturally occurring amino acid that has two stereogenic centers. And we're given threonine as a Fisher projection model. And we're asked to instead draw the four possible stereoisomers using wedges and dashes. And then for part B, we're asked, the naturally occurring amino acid has the 2s3r configuration at its two stereocenters. And we're asked which of the four structures that we're going to draw is the 2s3r. Okay, so to start, we'll start by drawing the four possible stereoisomers here. And so for each of these, what I'm going to do is start with carbon-carbon bond there, put the carboxylic acid to the top left like that. And then we'll put the amine here, and that's going to put a hydrogen on a dash there. And then the other carbon, I'll put this methyl group down there like that. And we'll put hydrogen on a dash there, and that's going to make the alcohol here on a wedge. Okay, so to derive the next structure, we'll flip the stereochemistry at one side but not the other. So one of the carbons stereochemistries will flip and the other will leave the same. So let's leave this one the same for right now. So that carbon is going to have exactly the same stereochemistry here. We'll still put carboxylic acid up here. And then we just need to flip how we had the amine and the hydrogen. So there we go. So then to get the other two, we'll just flip the other side. So what I mean is like this. So let's leave this like this. Hydrogen on a wedge, carboxylic acid up top. And now let's put our alcohol on a wedge, this hydrogen on a dash, and we'll leave the methyl group alone. And so now we just need to flip the left side carbon back, and that will give us our fourth and final stereoisomer. So C, OH, H, methyl group, carboxylic acid, and then back to hydrogen there, and amine on a wedge. Okay, so there are our four stereoisomers. And so now we need to determine which is the 2s3r. So if we start by numbering the carboxylic acid carbon as carbon number 1, that's going to make this carbon number 2 and this carbon number 3. And so we're looking again for 2s3r. So let's start with, okay, so 2s3r. So in this first one that I've arrowed, 1, 2, 3, so that's 2s, but it's 3s also, so that's not right. But so we do need that configuration. Oh, no, we don't. We need, so this is 2r rather. Right, because it would be Remember, to assign RNS stereochemistry, you want the hydrogen or the lowest priority molecule facing, or the lowest priority substituent on the dash. And then you start at the highest and go in order of priority connectivity. So for this first molecule, carbon 2, the amine would be top priority. The carbon with an oxygen would be second priority. And then the carbon-carbon bond to carbon 3 would be third priority. And so going in order, this is a clockwise rotation that we're making. And so that's going to be the R configuration. And so we're looking for 2s. So we want the opposite configuration. So that narrows it down potentially to these two molecules. So 1 and 4 here are out. So now we need to look at carbon number 3, and we want the R configuration there. So let's start where the hydrogen is already on the dash. And so the oxygen is going to be priority 1. The oxygen will be priority 1. Oh, that's what I did wrong. Okay, sorry. So right. So this should actually what did I flip here? Sorry, just give me 1 second. Right, so that's what I did. I drew the wrong things here. This should look like this. and I apologize. This should look like that as well. So I didn't actually flip anything. I moved stuff around, and I moved the oxygen, or I moved the alcohol and the hydrogen around, but I kept the wedges and dashes the same. So that's what's wrong there. So this should be dashed and this should be wedged. Okay, so there are our 4 stereoisomers. And so here, this makes much more sense now. So we need to consider these two, and we need the R isomer on carbon 3 here. So looking at this first one, we would go priority 1, priority 2, priority 3. So this would be counterclockwise. So this would be 3s. We don't want that, so it has to be this third molecule here, the only remaining one. That can be correct, but let's just double check. So this would be priority 1, priority 2, priority 3 again. And so this would be counterclockwise again. However, we need to put the hydrogen on the dash, and right now it's on the wedge. And so we actually switch this. And so although it would be S the way it's written, because we have to flip to put the hydrogen on the dash, this is R. And so this is the one that is 2S, 3R. All right, I'm glad I caught that mistake, because I would have given you the wrong answer. So these 4 molecules are now drawn correctly, and this third one is the 2S, 3R naturally occurring stereoisomer of threonine. And that's the answer to chapter 19, problem number 63.